This video is intended as a review for the first 3 Excel projects that we have done, and also it's a response to a lot of questions that I have already answered, but it seems like they need to be discussed again. So it'll be a video discussion of the functions that we have already reviewed and actually have used in our projects. So among the functions are if, minimum, sum, average, vertical lookup, count. We did not use count as such, we used count if, but it makes sense to discuss count first and then to explain count if in more detail. Also lower, proper, upper, and concatenate. This video will also include other topics. Tab references, that's for project 1 and 2, and this is for project 3, conditional formatting, color scales, fills, and icon sets. But we've got to start with a review of basic math terminology. This is not by any means a math course. However, as a tool, Excel was created to automate mathematical operations. So all the terminology which is used in explanations for all of these functions, all the terminology implies some knowledge of math, and that's what we're going to discuss first. So a quick look at projects 1 and 2. One important moment: you are asked to enter all different scores here for the My Score column. The reason for that is that you need to be able to check manually the average that you're going to calculate. Actually, all this is designed to give you an ability to manually check your calculations, because the formulas that you're going to enter may not be familiar to you. So be sure that all these scores are different. This formula, shown right here in the formula bar, seems to cause most problems in every semester. Most students require special attention given to this, so that's what we're going to do right now. You are asked to calculate my overall average. Overall here means weighted average, with the weights given in the weight column. So the first thing to review will be to recall what average is as such, and then what a weighted average can mean. The simplest definition from Google: the result obtained by adding several quantities. So we've got to have several quantities to get the average. In our case, these quantities are the grades that you give yourself. Adding several quantities together and then dividing this total. So adding means getting a total, which then has to be divided by the number of quantities. The mean is the same as the average, as in simple average. When they say the mean here, that means taking the average without assigning any weights, the numbers that we are summing up. In math, they're called the addends. We're not going to use this term, but we'll just say numbers. Okay, let's do a quick summation and addition here. You can tell that if I add 2 to 3, I'll get 5. Then if I get 4 to 5, I'll get 9. You're familiar with the sum function. It's done very easily, right? We're going to add this and this and that, and close the parentheses, get our number. Correct. So the first step has been performed here. Several in this case was 3. We added the quantities together got ourselves a total. Now to get the average, I have to use the total and then divide it by 3 because we have 3 addends. We have 3 numbers here, 1, 2, and 3. 2, 3, and 4. Okay, let's do that. We have D3, that's where we have the total, divided by 3. This is the average. Now I entered 3 manually just to make a point. Right here in the formula bar you can see 3, which I entered manually, and if you remember, I always tell you not to enter the numbers manually if you can, because the entire goal of using Excel is to design the model, what we usually end up with, the spreadsheet which is populated with formulas. It's called a model, and we need to avoid punching in the values as much as possible because we are hoping to reuse the model in the future. So to get this 3 differently, we can do a number of things. The easiest one is to use the count function. We're going to put equals count. Count will count the number of cells which have some characters in them. 1, 2, and 3. We've got ourselves 3. If we had more numbers, this would be a different number. If we had fewer, this would be a different number. Now we can get the average. And do it the right way. Total divided by the count. Same number. Let's go back to the numbers I used in class. We had a score of 100. Then we had a score of 90. Then we had a score of 80. Our average ended up being 90, and this is the unweighted average. I also explained in class that unweighted actually means that every number has the same weight. If I enter 1/3, 1/3, and 1/3, I will end up with 1. That will mean that 3 parts of equal size add up to a whole. Okay, just for visualization, let me enter 1/3 as text. When you enter numbers as text in Excel, okay, we're going to enter a single quotation mark right here. On the keyboard, it's this one, but you have to press Control. So it's 1/3. Okay, I entered these values so I won't waste your time, but I want to make a point of showing of the importance of the single quotation mark. If you simply enter 1/3, you get yourself 3rd of January. So just remember that. Once again, this is just to show you that all these numbers have the same weights. 1/3, 1/3, 1/3, which is also 33.33%. So they have to add up. These are actually numbers with weights, but the weights are all the same. Now imagine that I don't really think that these scores have the same weight. This test was not very difficult. This had some more difficulty added to it, and this one was the most difficult. So I will want the difficulty reflected in the average, because I can only give 1 grade for the whole class. I cannot have so many grades. So to reflect the difficulty in the average, I assign weights to these scores. So I decide to give the first score a 25% weight, 35 to the second score, and 40, the most difficult one, to the third score. Now I cannot have a simple average in which all scores have the same weights. The weights are now different, and that's what you're asked to account for in Project 1. As we have discussed several times, Excel tries to check your design intent. Therefore, it's going to try to figure out what you're going to do. Every time you punch in a formula, which we have over here, if I just copy it and put it in this cell, it figured I wanted to do the same. The original formula contained the counts on cells A3 through C3. The copied formula is counting A8 through C8, which is exactly what I wanted. And that's another point to make. Excel is a productivity tool. It's not gonna change here, so the scores remain the same. I don't need to do anything with this. But I do need to have a different average. So simply dividing the score by the number of addends, the number of numbers here, is not going to work. Now I have to account for the weights. I'm going to delete this now because it's useless. I don't need it. The weighted scores have to be calculated by multiplying the score by its weight. We enter the familiar signs now, equals this address, A3, times its weight. Makes sense. Here's another demonstration of the productivity feature in Excel. We got exactly what we wanted here, correct? Now, we can reuse the formula we have already created. We have sum of the values in 3 cells here. We can just copy this, throw it in a new place, and we have our grade. This is the weighted average. We have different weights. This is also weighted average, but because the weights are the same, they are all the same, we call it a simple average. So this is what you need to do for Project 1. But if you do it in the exact same way, which I have shown here, you'll have to use another column which is not included in the calculation here. So as I mentioned in the beginning, there are several ways of calculating the overall average. And the logic is the same. We use the sum operator. Now we use the weight multiplied by the score. We have to separate it by a comma because we need to give Excel the addends, the numbers to sum up, either as a range or as standalone numbers. And the hint here is not terribly informative, but you can see that the standalone numbers, number 1, number 2, number 3, and so on, they have to be separated by commas. Okay, these rules are called syntax rules. They must be adhered to. And another rule I mentioned several times, the parentheses must be even. The number of parentheses. We have this one here, we open the parentheses and we close it. Okay, we have this score weighted. We now have times this score weighted, comma, and we're going to have last score weighted. Close the parentheses. This is a must. We see it open here and close here, and we're going to hit enter, get the same result. This is a better way of calculating your weighted average for Project projects 1 and 2. Okay, next thing to review is the comparison operators. Using the if function, but basically they're used in programming a lot. And yes, if is the most logical start for all this. Equals, I think everybody knows that. Less than, greater than. To remember the difference, all we need to do is to remember that we write left to right as we write in English, and obviously as we read. So less than starts on the left and proceeds to the right. This number with which we start is less than the number to which we go. Same logic applies to greater than. We start on the left, we do the comparison, and go to the right. Okay, everything else is self-explanatory, but I'll just mention it. Less than or equal to, written this way because Excel or any other software which is not specifically designed to represent mathematical symbols will display it in this way. There are other programs that don't have to do this. Yeah, I just did this in Paint because I can. You may have seen it written this way. Sometimes you see it written this way. But in reality it's all the same. That's what we have here. So we're not going to use too much these two operators, less than and greater than, too much, but you have to be aware of them. And not equal to is the combination of less than and greater than.